This time, ladies and gentlemen, we're looking at a magnetics problem. We have a 1 meter long wire carrying 6 amperes, and we can presume that the wire is infinite. And we're just going to look at 1 meter's worth. And we're looking at the magnetic field due to an infinitely long wire. The field generated by the wire. There we go. Field generated by the wire. 1 centimeter away. We want to just look at 1 meter's worth of that wire for the forces. And this is the external magnetic field of 3 teslas. Okay. So first of all, let's figure out the direction of the magnetic field. We have to use the right-hand rule. So if the electrons are, remember this says the electrons are going, the diagram indicates the direction of electron flow. So the positive current flow would be in this direction. The negative current flow is given by the diagram. Point your thumb in the positive direction, in this direction. Point your thumb up. The curl of your fingers point in the direction of the magnetic field. So for this wire, the external magnetic field, if you point your thumb of your right hand in this direction, then your fingers are pointing up. They're coming out of the board on this side of the wire, and they're going into the board on this side of the wire. Now we need to figure out what the magnitude is. Now that we've labeled the directions, and you can even write the magnetic field generated by wire. It will have no influence on this magnetic field. This is how much the wire makes. And the forces will be determined only by the external magnetic field. Okay, so now, remembering Amperes Law, if you go around a circle, 2 pi times the distance away from the wire times the magnetic field has to equal mu0 times the enclosed current. So A, we've got the directions. We've already labeled the directions. We just need to calculate the magnetic field. Remember, R is 1/100th of a meter, not 0.1, but 1/100th of a meter. It's 1 centimeter. Oops. Meters equals 1 centimeter. Field generated 1 centimeter. Be sure and stay in the MKS system. And now it's plug and chug. Mu0, 4 pi times 10 to the negative 7th. Oops. Times the current. Current flowing through the wire is 6 amps. Divided by. Be sure and enclose the denominator in parentheses. 2 pi times 0.01 meters. I think I've got it. I've got 0.00012 teslas. B, force on the wire is I, length of the wire. This is where the 1 meter comes in. That's what L is, times B, and I'll make a note, external. That is the 3 teslas here, 1 meter here, and the current going through the wires, the force will be determined by the current going through the wire. Force, we need to think. Remember, you point so this time you point your thumb in the direction of the positive current flow, so your thumb is pointing up. Your fingers in the direction of the magnetic field, so your fingers are pointing into the page. The little circle with an X on it tells us the external field is going into the page. The current is going up. Your palm points in the direction of the force. So the force will be to the right. Oh, excuse me. Force to the left, or negative X direction. Okay, now we can get the magnitude. 3 times 1 times, excuse me, I6 L1 times 3. 18 newtons to the left.